All right, good morning, everyone. Thanks for joining us here today with the Xomnia breakfast. I hope everyone can hear me well and see me well. This is the first time for me doing it like this with such a large group. So welcome today on this Xomnia webinar. Today we're going to discuss how you can identify a good data science use case. Yeah, let me first quickly introduce myself. I'm not sure if everyone knows me or if Marcus already did it, but I think he was muted, unfortunately. So my name is Tim Reus. I'm an analytics translator here at Xomnia. And it's my job to actually bridge the gap between business and technical people, data science people. And to do this, I often am asked, can you please define and measure and do all these things on our use case and make sure that it works out? Create added value. So with this, we've been with many different companies, many different people. And in such, I've also seen that it's quite difficult for a lot of people to actually define and identify good use cases. As such, we thought we wanted to share our knowledge and our best practices with you today. So without further ado, I would say let's dig right into it. So for today, we have a few goals for you guys to learn, or actually to understand. The first one is to understand the importance of why we need to define use cases upfront. So in the past, it's been very normal to just start working on data science without actually thinking ahead or making sure that you measure the output very thoroughly. It was more on the lab phase and an experimental phase, and that's also part of data science, right? It is very experimental, but nowadays we want to make sure that it's also measurable. And the second goal that we want to give with you is what would be elements which are important for a good use case. So we've defined a few which might seem relatively straightforward to some of you, but trust me, I've seen it quite often in practice that people don't think about these stuff. And then on the third level, we would like to share some best practices on how I define use cases, or at least start off by defining use cases. So these are the goals that I would like to note to you guys, to the audience. Just one little note. Unfortunately, I'm not able to see the screen which is happening in the Google Hangouts. So this is why we have Mark and Casper as two of the moderators. So if you have any questions, just put them in the chat function, and we'll go back to that at the end of the presentation, or the webinar actually. And please remain muted and shut off your webcam just so we have the stability of the Google Hangouts. Thank you very much for your cooperation and such. So what's the agenda for today? So first we're going to discuss why would you define a use case? How do you find this and find the right problem to tackle with data science? And then how do you measure it? And especially the second part is something that, like I've already said, doesn't happen too often anymore, unfortunately. Then the second thing is what we're going to be discussing are the good elements of a use case. And then we go into how do we define them and examples of these use cases that a few that I've been working on. So let's dig right into it. Why would you define a use case? So over the years, since I've been working with Xomnia now, and also a bit before that, I've noticed that there's a lot of data going on, and people have a lot of data. Companies have a lot of data. But to actually change that data into something that you can use is something completely different. Making the data go from just data to information, or even to added value, is really 3 steps ahead. So this is something we hear a lot as well, is like, we have a lot of data, but how do we go from here, right? The second thing that I hear a lot is, oh, I want to use artificial intelligence, or I want to use machine learning. And what I would like to say to everyone who feels the same, don't do it. If this is your goal of using machine learning, then your approach would be wrong. Machine learning is just a tool to reach something. So your goal should not be, I want to use machine learning. No, your goal should be, I want to achieve this and this, and I'll do it by using machine learning, or I'll use artificial intelligence. The third thing that we hear a lot as well is, I have a great idea, and really this is going to be groundbreaking, but where do I start? And this is indeed a difficult thing, especially if it's your first time around working on a data-driven solution. Where do you start? Well, fortunately, I do have some experience with that nowadays, and it's also very difficult to know upfront. One, is it feasible to actually achieve that idea that I have? And if so, is it also economically viable to do so, right? You might imagine that you have a great plan, which indeed will get you some added value, but will it weigh up against all the costs that you still need to make? So this is an interesting concept, which we need to bear in mind for sure. And also the reason why I cannot stress enough to go for measurements in your use case. And the fourth thing that we hear so often as well is, we've created a great model and really something with added value, but there's no infrastructure to run it on, so I'll just have to run it in my notebook and send out the output via email, or put it in a shared folder or something like that. So while this might work perfectly for some solutions, I would like to stress out that thinking about how you're going to deploy something in production, right? So have it really integrated into your regular day, in your normal processes, is going to be key to making something a success. So this is something we're going to tackle on as well. So a few reasons for defining the right use case upfront is quite simple, actually. The first reason is the right use case is a right problem. And finding this right problem it might be difficult, and it's a challenge. So understanding this problem from an end user perspective, we eventually also make you understand, what is this added value that I'm going for? Is this the right solution? And by already thinking about this before starting the entire project, and already discussing with the end user, would this be beneficial to you and me? Then you can save yourself a lot of time and effort, and a lot of money in the long go. And in the end, you also want to have a solution which is being used, right? Not just to be built and to show off with, but you want something that's actually being used by the end user. The second thing is adding business value. I've already mentioned this a couple of times now, and we're not even 5 minutes down the presentation, according to what I think. But the idea is that you need to start measuring your success. You need to ensure that whatever is being built is indeed adding value. One thing that I personally always do is we start off with measuring what's going on before we even have a solution, right? So you could measure the time it takes to actually succeed in the process, or take the time it takes for you to get a response on something, or how much revenue you're generating. All these kinds of things can be measures that you can do upfront. So that would be your baseline. From there, you will start off by building something simple, and then make it more complex from there. The third thing, and third reason why it's really important to define the use case upfront, is actually the fact that data science is often perceived as a tech problem, right? It's all about technical aspects and what models to use in infrastructure and stuff like that. And yes, while that is important, it's more often a business problem. You want something to be resolved. You want to find new ways of doing business. You want to make your life easier, because you don't want to type in that data every time. You might want an automated solution. So it is very often more a business problem than just a tech problem. So finding the right people to be involved from the start is going to be key, while also striving towards engagement of these people is going to make the difference of a successful use case versus a failure. So I hope these 3 reasons are quite clear to you, but I would like to specify them a bit more. So this graph actually shows how we usually work with a Xomnia project, right? And I'm not going to go into the entire details because that is not something that is very applicable to this specific webinar, but I would like to focus on the first 4 points. And that is actually, where do we find our use cases? And it's relatively easy, and we're going to go through all 4 of them in just a second, but I would like to stress out one more thing. And while we're going to talk about where to find these use cases and everything, you should take into account one more thing, which is your data maturity. Every company and even every department has its own data maturity. And this shows how much is data-driven working or solutions integrated into your day-to-day operations, and how much knowledge is there. And this is something you should always take into account when defining use cases. Because if you're just starting to work with data or with data science, you might not want to go for the most difficult, most extreme models out there. You might want to start off with something which is a little bit more accessible, basically. And this sounds very evident. However, you might be surprised how often that's already going wrong. So let's dig into the first 4 things. So we're going to discuss the data places to find these use cases. And these are data insights, strategic topics, operational problems, and innovative disruptions. So the first one, and I would like to think also one of the most important places to find good use cases, are strategic topics. These are probably topics that management level or the board of directors or even your own manager has come up with in your department, which you should focus on, right? Cutting costs, getting more customer engagement, all these sorts of things. And they're a great place to start off by thinking, okay, if we're gonna do this, how can we do that? And could data science or data as a whole just have added value there? And often enough, corporate strategic topics are mostly the starting ground for use cases. However, they're too high level at times, right? We want to be sustainable as a company. Okay, what does that mean? What does that mean for people on the ground level, working with their hand in the mud, basically, what we say in Dutch. So you need to be able to bring it down. And that's also why these are quite often difficult. So let me go through a few of the examples that are written down, but there are legions of examples that I come up with for these. But one of them is actually, as a retailer, you would like to increase your revenue per order, right? So this means that every order that you have, you would like to have more on the revenue or more products sold. That could be one, or you could increase your pricing. Well, the second one might not be always the ideal one, so you would want to go for the first one often enough. So what you could do there is data-driven marketing, right? Really get the word out there, which is specific for people, or go for recommendations on your web shop. This is obviously something you all are familiar with while you're putting something in your basket, you get a pop-up, hey, you might like this as well. And another one is obviously dynamic pricing of products and services. So Google is a very good example of this, right, with their Google Ads. But I don't know if you know this bar in Amsterdam, they actually do the same thing, which depending on how many people are in their bar, they have their prices going up or down. It's an interesting concept, although that's not really data science, it's more of a business rule driven thing. The idea behind it can be data science. The second example that I would like to give you is getting sustainability into your workflow. And this could be for a factory. I think this is probably the most, the best topic to discuss, because this is a hot topic in the industry in this right now. So one way would be obviously to reduce energy consumption, right? And what you could do here is something that a lot of companies are doing at the moment, actually, is to see where does my energy consumption go to, and can we optimize this? Another way is to increase your life cycle of the machines, or your financial life cycle is often more the case, right? So the best example that I can give you here is the cooling mechanism that Google uses for their data centers. They had to redo their entire cooling system, but instead they used an artificial intelligence to get them a 40% decrease in energy consumption. And this is the reason why the financial life cycle of that whole cooling system has been expanded by 8 years. So that's quite incredible. Took them quite a while, but it was quite incredible. The second place for you to find a good problem, because that's what we're talking about here, problem and topics, are the operational problems. And this is probably the most common place to actually find use cases, right? So imagine yourself working on in an office, and you are working actually at the customer services, and you get all these letters coming in with suggestions and questions and things, and you're responsible for making sure that these letters go to the right departments. Well, this is something you could do as a person more than you're the best at it. But it takes a lot of time, it's cumbersome, and it might not also be the most interesting work every now and then. What you could do here is optimize that process by using classification on these customer letters to actually show, hey, this is about this topic, so it should go to that department. Hey, this is about this one, so this person should be involved. This really optimizes the entire process, which allows the employee to use their time on something they like better and maybe more valuable, and it speeds up the entire process. So optimization of operational processes is really a good start for any use case. Also think about driving options, driving routes, right? For taxi drivers, for garbage trucks, for anyone within on the road, basically. And then you also have something which I think any company which has a product to sell are really interested in, and that's stock inventory predictions. Imagine that you're working for this huge company, and it's really key to get your stock just in time, because everyone knows that having a large stock costs money, but saying no to a customer does not only cost you money, also cost you reputation. So getting these things right really help. Then there's another thing you could do within operational problems, and that's the first time right principle. Probably you all are familiar with this. It's really a concept that comes from the lean perspective, but data science can really help in this. So use picture recognition instead of manual entries, or use pre-validations within your processes. So if someone has to type in some sort of information or data into your system, put some validations. Does this make sense? Is this possible? If not, give it back straight away so you don't have the garbage in, which also means in the end you don't have garbage out. And then obviously you can still have some decision support tooling. So think about getting insights, predictions to you as a user, so you can make better predictions, so you can increase your decisions, and eventually also increase your tools and your targets. The third place is actually the most difficult place to find use cases. But if you find use cases here, they're often very valuable. So that's the data insights. So usually what happens here is that there's a business analyst or a data analyst or a dashboarding being created, and you stumble upon a finding, right? So this factory does way better or worse than all the other factories. This could be very, very, very relevant to actually create a model or a product which allows the other factories to also become just as efficient, or to understand why, or to increase the efficiency of that one factory which is not doing the right thing. Actually, this is how the LinkedIn network principle started off with. They had a data analyst working at LinkedIn who was looking at all the connections. So basically what you see on the right corner, right lower corner, is the connections that people had throughout LinkedIn. And he was thinking, if I know these connections and I know what is important to these people, we should probably be able to give them suggestions on who they would like to connect with as well. Well, as you can imagine, this really revolutionized the way we now connect with each other on social media. Another interesting part here is the churn predictions. As you might understand, for subscription-based processes, so think about your phone subscription, your TV subscription, Netflix, everything like that. The biggest problem there is if people cancel their subscription, right? So you don't want to have that. Churn predictions can help you actually to make sure that people do not cancel their subscriptions. How does that work? It's quite easy. You know, you do an analysis. What happened frequently in the past? Why people quit? And can we actually make that distinction in our current customer database to see, okay, these people are behaving similarly? Then we might want to approach them up front. Also a very good one, but very difficult to find once if you don't know where to look. Then the last one might be the one that for a data scientist is probably considered to be the most awesome thing to work on, but it's probably also the most difficult thing to work on from a business perspective, because it's innovation and disruptions, right? External forces that are coming in to challenge the way you do your business, or actually allow you to change your strategy so you do not lose your market position. Actually, we are in quite a disruption at the moment with the coronavirus. As you might notice, normally we would do this face-to-face, but now this digital way of doing a seminar like this is also fine, right? But people need to think differently and need to act differently. And the greatest example that I've heard so far was actually South Korea. They started off with this, having these drive-through testing sites for if you have a fever, yes or no, because then you would be more likely to have the corona virus. So that really brings out why people were going for it. Another thing is actually something that was happening a little bit earlier on as well, but really is taking a lift at the moment, is where universities and high schools changed from classroom teachings to online courses. And this is a very smart move, right? Because this means that they are not limited to their region anymore. Now they could provide their trainings, their lectures to everyone around the world, as long as you have internet, which allows them to get a whole new market out there. And Deliveroo has done actually the same thing, but then for the restaurant industry. They've opened up their limited space to the rest of the, well, city in this case. And the last example that I would like to discuss with you is actually the Google Smart Fill. And I don't know how many of you use Gmail, but this is something they do everywhere. It's where if you type in the first part of a sentence, the AI of Google already knows, well, predicts what you would like to, how you would like to end your sentence. And it's actually really good, and it saves you a lot of time and energy to, when writing an email. So these are the main places to find your use cases. And I would like to invite you, if you have any of these places or you have questions on that, to write them in the chat right now. So Mark and Casper can take note of it, and potentially they'll be discussed at the end. And while doing so, we'll move on to measuring of your use cases. And this is actually something which I've been stressing on for a bit already, and I would like to explain to you why. So, as I mentioned in the beginning, data science used to be very freely and discovery and very much in the uncertainty factor, right? Where it was considered to be a laboratory phase where you just see, okay, maybe we can add some value, maybe we know, maybe there wasn't any certainty in the outcomes of data science projects. And this has been going on for quite a few years until now, where basically data science has been coming into this thing we like to call the credibility crisis, right? How credible is it still that you can add value with data? And the best way to actually ensure that you are adding value is to do exactly the thing that all the data science have been saying to everyone else: start measuring, start collecting data. So that's what we need to do as a data science community as well. The first, and I would like to stress on this, that there are two ways of doing measurements, and you should do both. One is business measurements, and the other one is technical measurements. And you start off with at the start, and you do it again in the middle, and maybe continuously in the middle, but in the end, there should also remain a measurement of your project, right? So why would you need business KPIs? And I think this is very straightforward from my opinion, but I think it's very good to note, even though business KPIs are providing you with what is the added value of using this solution. And this could be a average order size. You could think about this time on page, or just your customer satisfaction, right? If you are able to deliver a response to your client more quickly and frequently, and better response, that would definitely help your client, even though it might not be the response that they wanted to hear. Or think about a chatbot, which gives them information quite quickly, so they don't have to wait for a representative to get on to be on the phone with them. Well, this is great from a business perspective. It's really important to get the technical measurements across as well. And I'll explain to you why. If you're working on a team and they're working according to an agile principle, they'll do a review every few weeks or so. During this review, your stakeholders, maybe you as a program manager or just the manager or product owner, will discuss, are you happy with the product, yes or no? That is great, of course, but that will requires you every few weeks, and let's say 2 weeks, you have to wait for 2 weeks on feedback. By adding a technical KPI, the data scientist or data engineer or anyone working on it from a technical perspective can actually already tweak their models, their work, so to the requirements. So you know upfront as a data scientist, hey, I can do better, or hey, I need to do better. And it's very important to set a target on these KPIs. You need to know when it's a success. It's an important thing for all of us to do, and it's actually something that I enjoy to do. And if you have any questions on how to do this, I would love to be in contact with you at some point to see if we can help you out there. So what elements are there in a good use case? I've already touched upon this in the beginning as well. Like, some things will be quite evident, but I think it's good to set the baseline before we start digging into how do you define the use case. So the first thing that really helps if you want to have a use case is it needs to be a recurring problem or a recurring activity. As you might understand, you do not want to waste a lot of money, because data science often costs quite a bit of money, for something you're only going to use once or once a year. That might not be enough value against the cost. So having a recurring problem really helps, and not just from a financial perspective, but also from an operational perspective. Because the more a problem occurs, the more likely you have a lot of data on this, which means that a model that you want to train on how to act with this problem has more input. which also means the output will most likely be a lot better than if you just had a few touch points. And that also brings me down to the second thing. You need to have the data available. And with available, I don't mean just via a, someone can manually export something. No, this needs to be something that you, me, and the data scientist, everyone who's in the project, because you don't want to give it out to everyone, of course, but in the project can access the data, but also will be able to see if this is everything that we need, or can we find something else? And then you want this on the right level of granularity. So a good example of granularity, and I'm not sure if everyone knows what this is, but this means the level on which you show your data, on when it's being aggregated. So a good example here is you could have your receipt in the while you go to the supermarket, and there you have every item listed, right? This is very low level granularity. But in your database, it might just show it was this ticket number and this was the total amount that was spent. That's a different level of granularity. Now, if you want to do a recommendation for customers, for instance, you need to know all the items that were on the list and not just the total amount, because that will not give you the insights that you need. So data availability and granularity are a good thing to think about before you go into the use case. Now, the third thing that I would like to mention is adding value for the use case, for the end use. I've been discussing through this quite a few times, and we'll come to an example where this was not done properly, but the end user needs to have the idea that this is going to help them out, especially if people are not familiar with working with artificial intelligence or data-driven solutions. It is key to have them on board from day one, because people need to be not just satisfied with the solution, but they also need to feel like they can trust the solution, trust the artificial intelligence, trust the model to make the right decision. And the only way that's going to happen is by including them and by explaining to them what's going on. And adding value will help in the total regard of making the use case a success. And then the last part is the ability to run in production. I've already touched upon this in the first thing, where we hear people saying, well, I've run it on my notebook and I've just sent it out through the email. This is a cumbersome thing and not always likely. So think about where do we run this? Is this going to be something we can run in an existing application? Do we need a cloud function for this? Are we going to build something entirely new? And what are the restrictions on this? So for many large companies, this is the most difficult part to achieve, right? Proof of concepts can be done, that's not a problem. But actually integrating it into the technical environment that it's properly being used by, it's properly being managed, is really difficult. So this is, I cannot stress this enough, but this is key to actually do properly. Think about it, know about it, and also if you have hesitations on this, you should contact probably someone who can help you out there. So how do you define the use case? Where do you start? And before we dig into something that I've built for my own use, I would like to mention one thing. You might feel like you're on your own at the beginning. Like you have an idea, or you see the option, or you're a data science manager, and you're looking for these use cases. But where do you start, right? And it's important to realize, especially if you are not from a technical background, but more from a business background, or the other way around, you will need other people in defining these use cases. So what we've done, we actually use this thing called the use case canvas. Similar to maybe something you've known from different backgrounds. I know this is being used also for corporate strategies and everything, just a canvas. And we've created something which helps us define the use case. And based on this, we can say, okay, we can do this, or ooh, this is going to be rough, or it's going to take us a longer period because of this and this and this. So let's go through them one by one, and we'll start at the left top corner. So what is the supported goal of this specific use case, right? So you have an idea, and what is the goal that this is being supported by this use case? So these are probably one of the 4 things that I mentioned that that produces a use case, or where a use case originates. So strategic topics, innovation, disruptions, data insights, or operational processes. That's probably something you would like to mention there. And we'll go through some details in a minute, but that's very key, because then you know, why are we doing this? If we move to the right, you'll see the objective, right? Even though we know there's a goal that we support, you should have a very clear objective for this specific use case. And this could be, we want to reduce our carbon footprint, we want to achieve more revenue by doing yada, yada, yada. This can be very elaborative, but this is actually the reason why you think this would be a good use case. If we then move to the right again, you see the success measurements. I think I've covered them quite a bit, but it's important to already think about them ahead. What could be the measurement of success? And if you already know the baseline, for instance, you know the amount of revenue that is being collected through a certain, I don't know, a certain product, that would be great to already mention here, of course. But if not, that's not a problem. Just make sure that you think and talk about what could be a success measurement. Then if we move to the right again, you actually see the infrastructure. Think about who is going to maintain this from a technical perspective. Where is it going to run? What applications will be needed to do this? Or are we going to create something else? If we move to the middle left, we see the data required. And this is probably where you're going to need either a data scientist, a data analyst, or someone if you are not technical. Right? So what would be information that would be relevant for this use case? So if we think about the recommender for a moment again, right, you know you're going to need that order from a customer. But you probably also need to know something more about the products. You probably also would like to know a little bit more about the clients. So these things you can write down here. So then you see 3 different blocks which have a different color. And these are not so much technical things you'd like to define or business things you need to define, but these are the people that you need to define that will be important to make this use case a success. And I've already mentioned this, right? It's often a business problem, data science, and more often it's also getting the right people involved. And this is why they're centralized in the use in this canvas as well. Because in the end, if these 3 blocks are not managed properly, the rate of your success of this use case will probably decrease dramatically. So the first thing is the use case owner. Who would be the one to actually pull this use case? This could be yourself, right? But this could also be a manager of a certain division, or maybe your CTO, or maybe you want your CIO. If this is really important enough, this could be the person you need to report to. And this is the person that you would like to get on board as much as possible, while also maintaining a little bit of a distance. Then if we move to the down one bit, you have the end users. I think I've already mentioned it quite a few times, but you need to know who your end users are. Because if you don't know who they are and what their interest is, you'll never be able to know if the solution is something they will be able to work with. And then we still have some other stakeholders. Now, this could be an IT department, but this could also just be different departments who are looking at the way you do it, or you need to report to, or you need something from them. It could be third parties as well, external parties. For instance, if you want to do something in Azure, Microsoft Azure, then Microsoft might be a stakeholder here. If we continue to move to the right, we see the type of models. Now this is another aspect where you're definitely going to need your data scientist for, and that's at the beginning, start to think about what type of models we could use to actually solve our problem. And I'm not saying this is definitely going to be the way you're going to do it in the end, but it's good to already have a thought about this. And why? It's because you need to know, do we have these capabilities in-house? If you don't have them in-house, you have two options actually. The first option is say, okay, how do we get these capabilities on board? And how long is it going to take? And are we going to delay the project as such? Or B is, how can we get this externally, these capabilities? And if that's the case, usually you need to know a little bit better, okay, what kind of capabilities do we need and who do we need to talk to do so? So it's really important, because then you get another stakeholder involved. If we move one more block down, we have the potential impediments. Working with data is interesting. You know, there's a lot of things to be done, but if you might not work with data all the time, or you do, but there's a good chance you've heard about the privacy and security laws, GDPR, or anything like this. And this, if you don't think about these potential impediments, problems, if you will, that you encounter during your project, it can slow your entire project down, or even cancel while you've already started. A good example here is using personal data without having a good reason to use it, right? GDPR specifies that, you know, having personal data and use this is not something you can do without a good reason. And thinking about this and actually specifying this really helps you in the end. And then we've also created a bottom bar which says comments and specialties. But that's just something to think about if there's anything else. So I have a few examples, and I would like to go through them quite quickly because of the time. So the first thing is actually fraud predictions on vacation home at the municipality of Amsterdam. So if we go through what are the use cases here. So this is actually a very interesting one because of this, the supported goal here. The mayor of Amsterdam actually announced that they really want to tackle Airbnb fraud, as they called it at that time. So this was a strategic goal coming up from the highest places of the municipality. And the objective here was to counter the growth of fraud with these vacation homes. And how they measure the success is by how often did the model predict the vacation home that there was going to be fraud there, and how often is this model right. So when they went to see the house, it actually was the case. Now I'm going to skip the infrastructure bit, but the interesting part is that they had their own infrastructure. And they really wanted to have it in a certain way. So that really elevated and made it more difficult. So if we look at what kind of data is required, it's going to be historical records, it's going to be demographic information, event calendars, because you might imagine if they're during King's Day, the amount of people coming into Amsterdam really elevates, and a lot of people rent out their houses. But of course, for potential impediments, GDPR is a big issue. How do you use that information on demographics, on homeowners and stuff like that? And then one more thing is why, which was really interesting here as well, is that how do you define fraud? This was different throughout different places of the municipality. So that's where one of my colleagues, Robin, started working. How do we actually identify what is fraud here? And then the middle part, as I mentioned, this is the core. And you can also see that they've really put in, it was a strategic goal, so there were a lot of heavy hitters on board as stakeholders. So you see the directors of the director of the chief tech office, the director of public safety, the manager of order and oversight of the living department, on and on and on we go. But the idea here was to have the fraud inspectors use these predictions to actually visit these homes. And that's what they do now. They have a tablet, and there's a priority ranking based on this prediction. So that was really useful. If we look at something that wasn't a best success, it would be this example. And this would be the predicting of available beds in a nursing home, and which is very relevant at the moment, of course. But I'll show you why it wasn't the best success, and we could have known this up front. So this was an operational problem. The planners of the nursing home had no idea when a bed would become available, and they didn't know how to forecast this properly. So the objective was to provide them with predictions on available beds in the different rooms, but also the different buildings that they had in their nursing home. And as you can see straight away here, there was not a measurement of success, which already provided us with the first problem. How do we know it's actually working good enough? Then if we look to the infrastructure, this was something that they wanted to see on the Google Cloud platform, but maintained by a third party. So that is an interesting part which gave us more difficulty, more complexity for the use case. And here again, the data required was the capability of the housing, the requirements of the house, the room characteristics, on and on we go. And the potential impediments here was actually the fact that the data would come in through manual uploads into the Google Cloud platform. Now, this is something you might, if I would have known this upfront, I would have put that in the infrastructure part. But unfortunately, we only knew that while we were doing the project. So yeah, that's interesting. And also, of course, privacy is very important here. And then if we look again to the core, is that we see that we didn't know who was going to be the end user of this product, of this solution. Even though John, the senior planner, was our owner, and in our opinion, also the end user, turned out it wasn't the case. So what happened was a very over-engineered application, which would run even if basically if the world were to collapse, it would still run fine, but it was never used by the end users because it didn't give them enough added value, and it wasn't something they could use properly. So as a result, after a year of running in production, the solution was decommissioned. And here you can see very properly that not having all of these building blocks in place really, it didn't help us make this a success. And then the last example that I want to do, because I think I'm running out of time, is something that we're currently doing with in the inland shipping, and that is creating semi-autonomous inland ships. Maybe something you've heard before, and it's called shipping technology. And here we look at it from an innovative and disruption perspective, right? We've seen Tesla move to automated autonomous vehicles. We see people in companies in Scandinavia who are building newly built ships and make them autonomous. And the idea that we had was actually make existing ships and make them more smarter and have them semi-autonomous, which means there will still be people on board. For the measurement of success, we have defined quite a few. And the first one is the number of connected ships. And you should probably know for this, we need to install a black box, so to say, which collects all the data and then sends that over to the cloud. well, this black box needs to be installed. So that is one of the measurements of success. Another one is actually the accuracy of our predictions. Are we going to predict? Are we going to predict these collisions accurate and precisely with static objects? So think about ports, think about bridges, stuff like that. And then obviously, how long can a ship run autonomously during our tests? That was also a measurement. Then think about the data that's going to be required. We need to know all the sensor data on the ship. So the speed, the pilot, the heading, but also we need to know what is a captain doing at that specific time. So are they making changes, or are they looking at their radar? And the radar image is actually one of the main advantages here as well. Then if we look at who's going to be a use case owner, that's actually the director of shipping technology itself. Whereas the end users are very important here. They're not just the inland ship owners, but also the captains on board. And there's a big difference in how these two people want to interact with models. So that also explained to us that we really need to think about how we're going to do this. And then obviously we still have a few impediments. For instance, the availability of the test chip that we have. There are a lot of regulations about how can you test autonomous vehicles, even though they're on water, and especially if they're on water, maybe. And then obviously, and how does a ship send their data to the cloud? So we need internet connection. And that's very much of an impediment if you are in Germany. Maybe you've seen it while driving there as well. So, and then there are some comments. So hopefully you've seen that by taking down these boxes, you can already start thinking if this would be a success, yes or no, and what else you need to think about. The idea of having this conference really helps in defining upfront, what am I going to do with this use case? I hope you've had some interesting insights, and I hope I can help you out here. If you have any questions, please type them in the chat right now, so Mark and Casper can ask them. But also feel free to contact any of us if you'd like to think over it a little bit more in the end.
Thank you very much, Tim, for the presentation. I think we have time to answer some questions, and everybody also thanks for the interaction in the chat, and thanks for keeping your mics turned off and also your webcam. I see some questions pouring in, but I want to start with a question of Kim. Tim. The question is, how do you get use cases right when business has a lower maturity level, yet expects and needs for market a high data maturity level?
Yeah, that's a very good question. So,
I thought the same.
So, the question is twofold, and I'm going to try to answer it twofold as well. So the first question, Kim, was how do you get the right use case if the business is not mature enough, right? So the answer here is that you need to help the business. So you need to help them provide a certain level of maturity, give them information, and also create certain workshops where they're not necessarily understanding that they're giving you the information that you need. But so this is something that I do quite often, is have a workshop with people who are definitely not tech savvy, right? But I'm just going to ask them about how their process works. What's their day-to-day work life look like? What are the issues that they're connected to? Or what are the applications that they're currently using? Is it Excel, or are they using a web-based interface or something like this? And then I'm not asking them to make the definition for me. I'm just making the definition myself based on the information that I hear. And then I can come back to them and say, hey, this is what I've heard. I think this is a good idea. What do you think? So that's the answer to your, hopefully an answer to your first question. And I must admit, what was the second part of the question, Mark?
Yes, let me look it up. How do you, I will explain the question or read the question again. How do you get use cases right when business has a lower maturity level yet expects and needs conform market a high data maturity level?
Right. Yeah. And the second one is very interesting, right? The maturity level of any company or any department should, in the end, not matter if you have the right solution. However, in order to get that right solution, someone, and probably a good team, will need to have that high maturity, because getting a solution to the people right the first time around, if their maturity level is quite low, you need to compensate for it, because I can give you a solution which seems very easy and something they can use very likely, but only because I know how to do that. I've been through that decision a lot of times, right? So somewhere in the organization that lack of maturity needs to be compensated. That's how you deal with that. I hope that answered your question, Kim.
Yeah, let's get on with some other questions. I see the questions pouring in on the chat. We are also taking notes here from Xomnia, and we will get them answered for you if it's not being on topic right now. Next question, Tim. It's from Meike. She said, in my experience, it's difficult to determine when a model is done. Because if you spend more time, you can often reduce your error just a bit more. But it may not always be worth it. I noticed you don't specify hard success measures, as in X should decrease by Y. So do you have any advice on determining what's good enough?
Yes, actually, that is a great question, and it's a question that I'm struggling with on a day-to-day basis myself as well. And the answer to this is still twofold, right? So there's a reason why I'm not going to for that very hardcore measurements of X decreases Y on a certain measurement, because if we do this properly, the first two measurements, so the business measurement that we said and already a technical measurement, should be connected to that very, very hardcore measure. Now, at some point, there is a trade-off between what's going to be improvement versus the time and effort that you spend into this. And this is different for each and every one of the use cases. So there's not a hard measure or a hard line to follow here. But the thing that I would recommend is always plan upfront, how, at least give an idea on how far can you still increase the model on that perspective, and how much time and effort do you put into it. And ask the people that, you know, your product owner or the business, is this worth it?
Cool.
I hope that answered your question, Meike.
And then for the last question, and I really like this one because it's about your opinion. In your opinion, it's from Jeffrey. Who is better suited to finding a good business case? The data scientist who has more technical knowledge, or the business user who knows more about where the problems are in the business?
This is for me an easy one, because I really feel the people from the business should be able to find the better use case, and I'll explain to you why. First off, I really feel data science is often a business problem, right? I've mentioned this quite a few times, but also it's not that big of a deal on. And don't get me wrong, right? It might sound more blunt than I mean, but in the end, you want to solve a solution, something that's really going on in the processing, into the day-to-day business. And however, data scientists are great and have a lot of knowledge and know quite a bit. But and their role is actually designed as such, right? Where they have knowledge on computers, knowledge of statistics, and knowledge of the business. Now, this is a unicorn in my opinion. That's actually why my role has been created, because that understanding of business is very difficult. So for me, it makes more sense that someone from the business would say, hey, I have a problem. Can you solve this? So in the end, it's going to be something that should come as a joint collaboration. But in the beginning, I think that people from the business would be able to make a better use case. I think that answers your question, Jeffrey.
Cool. One last question, and then we are going to end the webinar. It's from William, and the question is as following. How would you handle a longer period, say a couple of months, of potentially biased data when training a model? Simply omit this data, or are there smarter solutions to still make use of this data?
So this depends. If you having biased data is not necessarily a bad thing, because if that is data that is it's biased because that is what you've done your business with so far, then it's better to have that specific data than no data at all. However, it also depends on how you're going to use that data, right? If it's biased and really people's lives are on the line, then you might not want to do this. But if it's about supporting a decision, for instance, you want to give them insights on what would be an interesting product, it's not necessarily a bad thing to have that bias in there, as long as people are aware that there's a bias into this.
Cool. Thanks for answering, Tim.
You're welcome.
Everybody, thank you very, very much for joining. Feel free to reach out to us, or feel free to reach out to Tim. His email is on the slide below that you're seeing him presenting right now. Thank you very much again. We would like to say take care, especially during this kind of crisis and situations. We will stick in this for a little bit longer, so maybe Tim, you can talk a little bit more through, because I need to do some things with all the questions that are being asked and not answered. Thank you very much for coming, and we would like to see you again in this kind of format, but rather see you in person again. Thank you very much.
Thanks, everyone. I hope you enjoyed it. Bye.